Hello everyone. In today's lecture, we will discuss conclusions that we have drawn from everything we have discussed earlier. Students, when we have started our book, then I have discussed about symmetry. And while discussing symmetry, there was a concept of checking the invariance of our differential equation. Actually, our course is based on the symmetry analysis of ordinary and partial differential equations, but first of all we have discussed ordinary differential equations to get a better idea of it. Okay, and there we have discussed about finding the invariance of a condition under the given Lie group, and then after that we have discussed the idea of infinitesimal transformations. Okay, infinitesimal transformations, and there we have developed a technique for finding the value of capital X and capital Y. And what was the benefit of finding the value of capital X and capital Y? Obviously, these values will convert our given ordinary differential equation into a separable equation. Okay, and if we are given the partial differential equation, then definitely one of the variable will get reduced in the procedure. Okay, and this procedure we will discuss in the coming lectures. Okay, but here the idea is this: the infinitesimals will convert, or by using the canonical variables we can convert our given ordinary differential equations into a separable equation. Okay, then we have developed a technique, and we have defined a Lie's invariance condition, and there we have discussed that if we are given the ordinary differential equation, let's say y prime is equal to f, or that is a function of two variable like x and y, where x is independent and y is a dependent variable. Okay, we have developed a Lie's invariance condition, and we have discussed there, if we are given this equation and we are given the values of capital X and capital Y, or we are given the Lie group, then we can find the invariance of a condition. Instead of using these values in a given differential equation, we just substitute these values in the Lie's invariance condition, and if that condition is identically satisfied, then we say that the given differential equation is invariant under that Lie group. Okay, now students, then after that we have developed the idea about the infinitesimal operator. And while discussing the infinitesimal operator, we have discussed about the extended operator. And what was the benefit of it? Like here we have developed the Lie's invariance condition, that is gamma 1 of delta at delta is equal to 0 is equal to 0. And here we have discussed that if we are given the value of capital X and capital Y, we just need to substitute the value in this term, and if that term is equal to 0, then we say that this equation is invariant under the Lie group. Means the whole crux of this procedure is that we are trying to reduce our calculations. Our main focus is on finding the symmetries. Okay, as you will easily see that in the coming lectures I will discuss that by using these Lie's invariance conditions, or the extended form of these ones, we will find the symmetries of a given differential equation. Like in the previous chapters we have discussed that the given differential equation is invariant under some Lie group, and symmetry like x and y, infinitesimals are given over there. But here we will find the infinitesimals, and then after that we will check that by using those infinitesimals we will find the canonical variables. Okay, now students, this is actually the main idea of what we have discussed earlier. Now in the coming lectures we have discussed about the extended form of these operators. Okay, thank you so much.